We will now verify this statement, that is the derivative of a cubic polynomial function is a quadratic polynomial function. So let's consider the general form of a cubic polynomial. So I'm going to write down this as f of x equals ax cube plus bx squared plus cx plus d. So this is the general form of a cubic polynomial function. Notice that a cubic polynomial is considered a cubic polynomial if the degree of the polynomial is 3. So here clearly this polynomial is cubic because the degree of this polynomial, that is the highest power of x, is 3. So this is a cubic polynomial. Now let's differentiate this both sides and verify whether it is giving a quadratic polynomial. So I take the derivative on both sides. I put the derivative symbol like this, and then the expression on the right, that is ax cube plus bx squared plus cx plus d. Now we can find the derivative. This could be written as f prime of x. Derivative of f of x is f prime of x. Now to find the derivative of this polynomial, which has sum of 4 terms, we can find the derivative of each term like this when we use the sum rule of derivatives. So I put like this, that is ax cube plus differentiation of bx squared plus derivative of cx, then derivative of the constant d. Now I can use the constant multiple rule and factor out the constant, because the constants are a, b, c. In fact, this last derivative will be 0. So let's factor out the constants first. And when I do that, I get a times of derivative of x cube plus b times of derivative of x squared plus c times of derivative of x plus this derivative of constant. This is according to the derivative rule. This is 0. Now I can use the power rule of derivative. That is, if you differentiate the function x raised to the power of n, this is equal to nx power n minus 1. That is, you take the power of the n, put it in front of x, and raise the x to the power of n minus 1. So same thing I'm going to do here. That is a times of, we have the power as 3 over here. So I'm going to put the 3 in front. So therefore this becomes 3 times of, and then I raise x to the power of 3 minus 1. So it's basically 3 minus 1 is 2. I'm going to put that over here. So it is x squared. It becomes x squared. And similarly, I have the constant b. And then here I have the power as 2. So I'm going to put the 2 in front. X raised to the power of 2 minus 1, which is 1, plus c times of. Here you can consider this x as x raised to the power of 1. So once again, I'm going to put the 1 in front and raise x to the power of 1 minus 1. Then we have this constant 0, so we don't need to put that. We can ignore that. Now let's simplify this. So it's going to give us 3ax squared plus 2bx plus c, x raised to the power of 1 minus 1. This is 1 minus 1 is 0. So x raised to the power of 0 is 1. So basically c times of 1 is c. So this is the result that we get when we find the derivative of a cubic polynomial. Clearly this is a quadratic polynomial because the degree of this polynomial is 2. We can see that the highest power of x is 2. So it is a quadratic polynomial. So now we can have some more examples to understand that. So I'm going to give 2 examples. That is, example 1 for a cubic polynomial is, we can consider this as a cubic polynomial, that is 3x cubed plus 2x squared minus of 6x minus of 7. This is example 1. And let me give one more example, that is negative x cube minus 5x. So these two are cubic polynomials. Let's find its derivatives over here. I'm going to find the derivative of these polynomials. So when I take the derivative of this polynomial, this implies uh, I apply the power rule as well as the constant multiple rule. So I'm going to get 9x squared plus 2 times of x is 4x minus 6. So this is the derivative of this cubic polynomial, and the derivative of this cubic polynomial is negative 3x squared minus of 5. So clearly these two are also quadratic polynomials because the degree of these polynomials are also 2. Clearly we can see that the degree of the x is, the highest power of x is 2 over here. This confirms it's a quadratic polynomial. Similarly here also the degree of this polynomial is 2. So therefore these are quadratic polynomials. So we can observe that anytime that we find the derivative of a cubic polynomial, we are always getting the quadratic polynomial. So we can confirm that it is always true. The given statement is always true, and the important reason behind this is uh, a cubic polynomial is having a degree, has a degree 3, and a derivative of a polynomial with degree 3 will always be a polynomial with degree 2. Degree 2. And a polynomial with degree 2 with degree 2 is considered a quadratic polynomial. So this is the reason for the statement to be always true.